Hello and welcome to this tutorial on building and running a Bluetooth application for the Murata Type 2 FR Evaluation Kit. The Murata Type 2 FR Evaluation Kit is a ready-to-use board for developing with the Murata 2FR wireless module. It runs free RTOS and works seamlessly with the NXP MCU Espresso IDE. This means you can develop, build, and debug Wi-Fi applications all in one place. The board includes onboard antennas as well as connectors for conducted testing, making it flexible for a range of wireless development projects. For required hardware, you'll need the Murata 2FR Evaluation Kit and an MCU Link Pro debug adapter for programming and debugging. Before we start, let's make sure you have everything you need. You'll need the Seger J-Link software, the MCU Espresso IDE, and a terminal application like TerraTerm or PuTTY. If you've already completed the hardware configuration covered in our previous 2FR setup video, you are all set. If not, we recommend watching that video to ensure your board is connected and configured properly. Open the MCU Espresso IDE. In the Quick Start panel, click the button labeled Import SDK Examples. When the wizard opens, select the RDRW612BGA target board. This corresponds to the NXP RW612 chip used on the 2FR module. Click Next. This wizard allows you to import sample projects, so you can start with working code. Next, select UART as the option for the SDK debug console. This ensures that debug messages are routed through the board's serial interface so we can view them using a terminal application. Then, under the folder named Edge Fast Bluetooth Examples, select the project called Peripheral_HT. This stands for Peripheral Health Thermometer. Click Finish to import the project into your workspace. You should now see it listed in the Project Explorer. Before building, we need to update a couple of files to ensure compatibility with the Murata 2FR hardware. First, download the file named flash_config.c from the Murata community forum. Then, replace the existing file in your imported projects folder with the new version. This will ensure the flash settings match what the 2FR module expects. Next, download the file named mflash_drv.c from the Murata community forum. Overwrite the existing version in the directory shown in the slide. This updated driver helps handle flash memory operations correctly on the 2FR board. Now, let's disable a low-power feature. Open the file named edgefast_bluetooth_app.h inside the sources folder. Locate the flag called app_low-power_enabled. Change its value from 1 to 0. Disabling this feature helps keep the Bluetooth radio active, which is useful for testing and demonstration. We also need to update the flash memory region setting in the IDE. Right-click on your project and choose Properties. Navigate to C/C++ build, then select MCU settings. Find the field labeled Little FS Flash region. Set the location to 830000 and the size to 100000. Click Apply and Close. This ensures your application knows where to store data in flash memory. With the configuration complete, let's build the project. Right-click on the project, go to Build Configurations, Set Active, and select Release. Then, click the Build button in the Quick Start panel. The IDE will compile your code into an optimized binary file, ready to be programmed into the evaluation kit. Next, let's flash the Bluetooth firmware onto the module. In MCU Espresso, click the GUI Flash tool icon. If it's grayed out, select the project in the workspace, then try again. When the Flash tool opens, choose J-Link as the debug connection and click OK. In the Flash tool interface, click File System. Navigate to the folder shown and select the firmware. You might need to switch the filter to show .bin files. Set the base address to 8540000. When the process is complete, click OK. The Bluetooth firmware is now programmed into the module. Let's see the application in action. Open TerraTerm or PuTTY and configure the serial connection. Set the baud rate to 115/200. Use 8 data bits, no parity, and 1 stop bit. Set flow control to none. You can also adjust the terminal window size and line ending settings to make the output easier to read. Back in MCU Expresso, click Debug on your peripheral_HT project. The IDE will flash the application onto the board. When it's done, you can either stop the debug session or leave it running to watch real-time messages. The binary is now installed and ready to run. To test the demo, download and install the IoT Toolbox app from NXP. It's available in the App Store for iOS or the Play Store for Android. Launch the app and select the option called Thermometer. This tool is designed to connect to a Bluetooth device that broadcasts temperature data. Your evaluation kit should already be sending that information. In the IoT Toolbox app, look for a device named peripheral_HT. Tap on it to connect. The app will pair with your board and start receiving temperature readings or other Bluetooth notifications sent by the demo. You'll also see a pairing confirmation appear in the TerraTerm terminal window. Approve the pairing in both the terminal and the app. Once connected, the app will display live temperature data, and the terminal will show logs from the running application. This confirms that your Bluetooth link is working correctly. And that's it. You've now successfully imported, configured, and built a Bluetooth demo project for the Murata Type 2 FR evaluation kit using MCU Expresso. Thanks for watching.